Let's now solve this higher order non-homogeneous differential equation. Here we have the fourth derivative of x minus x equals cosine of minus 2t. First, let's write this in an exponential form. This is the same as e to the minus 2t, the real part of this. So here we have, let's first find the homogeneous solution, the solution to the homogeneous equation, and then the particular solution. So the homogeneous equation would be the fourth derivative of x minus x equals 0. So the polynomial applied to x, we could say it is d to the 4 minus 1 applied to x equals 0. So the characteristic equation is r to the 4th power minus 1 equals 0. This is a square difference of squares. R squared plus 1 times r squared minus 1 equals 0. This is the difference, square difference involving I. So it's r plus I times r minus I. And this is another difference of squares. It is r plus 1 times r minus 1 equals 0. So the roots are r equals to 1 minus 1 and plus minus I, just once. So I would say x sub h of homogeneous, the solution to the homogeneous equation, is e to the x, c1 e to the x plus c2 e to the minus x plus would be e to the 0, because here we have 0 plus minus I. And remember that we just take the plus I because plus I has cosine and sine. So it is just cosine of cosine of t, c3 cosine t plus c4 sine t. And now let's find the particular solution. So we say we have an exponential function, so the particular solution is equal to, would be that same thing, e to the minus 2t divided by the polynomial of a. This is our polynomial of a. The polynomial is equal to the alpha polynomial. Here alpha is minus 2. This is true only if we have that alpha, that the polynomial of alpha is different to 0. So let's see what is the polynomial of alpha when alpha is equal to minus 2. We have, here, we have minus 2 to the 4th power minus 1. This is 16 minus 1, so 15. The polynomial of alpha is 15. It is not 0, so we can use this formula. The particular solution is e to the minus 2t over 15. Alright, first, well, here I have e to the minus 2t over 15. Now I could say this is cosine of minus 2t plus I sine of minus 2t over 15. So here I have the real part and the imaginary part. Here I just say this is equal to cosine of minus 2t. So I would need to take just the real part, that would be just cosine of minus 2t over 15. So we have, let's say, x equals C1 e to the t plus C2 e to the minus t plus C3 cosine of t plus C4 sine of t. If I say plus e to the minus 2t over 15, this is the generalized solution to the differential equation. But if I say x equals to C1 e to the t plus C2 e to the minus t plus C3 cosine of t plus C4 sine t plus cosine of minus 2t over 15. This is the solution to the to this equation. So this is the solution to the differential equation, which is this equal to e to the minus 2t. Now if I'm just taking the real part, so the solution of the differential equation equals to just the real part of this complex number is just the same. Just instead of here putting e to the minus 2t divided by 15 is cosine of minus 2t divided by 15. See you next video.